So does a quadrilateral, a regular quadrilateral, does that tessellate the plane? We'll see, but according to the angles, it sure does. It's a factor of 360. So, will this pattern always work? Do all regular polygons tessellate the plane? Because it seems like it works. Let's check some more. So let's check 5. So again, applying our interior angle sum theorem, we get 540. 540 divided by 5 is 108. Does 108 go into 360? No. So will it ever work again? Or is it just triangles and squares? Well, let's see. Let's try 6. 6 subtract 2 is 4. 4 times 180 is 720. 720 divided by 6 is 120. Does 120 go into 360? 3 times. So that does work out. Okay, so this is going weird. It's going yes, no, yes. Are there any other regular polygons that will tessellate the plane? No. And if you're interested, you can explore why there are no other ones that do tessellate the plane. But that's all that we need to know. So that gives us 3 options for regular polygons that tessellate the plane: squares, equilateral triangles, and equilateral hexagons. Those are pretty boring shapes though. They're just regular polygons. Let's see if we can make them a little bit more interesting. Recall that we've only really considered the angles and not the sides, so that's how we make them more interesting, is changing up the sides. In order to tessellate the plane, there need to be no gaps and no overlapping parts. That's something that we've repeated many times throughout this presentation. The easiest way to ensure this to happen is simply to create a cutout on one side and move it to the opposite side. Okay, so if you're thinking to yourself, I'm still not following, what do you mean? We've got some pictures, because pictures are worth 1,000 words. So don't be scared, this is easy. So step 1, you're going to get a square, or you could also choose to do a triangle or a hexagon. Again, all 3 regular shapes that we're talking about work. So in this example, we're going to use a square. So step 2, you're going to draw a shape from one top corner to the other top corner. That shape can be anything. It could be squiggly. It could have curved lines. It could have straight lines. It doesn't matter. Just start in one corner, go to the other corner. And actually, technically, you don't have to even go from corner to corner. As long as you aren't going back to any other sides, you can go anywhere on the top to anywhere else on the top. Step 2, move that shape that you just did to the bottom. Now here's the reason why doing corners may help. When you do the corners, you can line up the corners on the bottom, because the placement on the bottom matters. That is important. So you're going to move it straight down. Again, it doesn't have to be on the corners, but it can be. Next, you can repeat the exact same process, taking a piece out of one side and adding it onto the other side. So you're moving and taping that to form a new shape. And now this shape, although it's based on a square, has this exact same area as the square. There's no overlaps. This shape is much more interesting, in my opinion, than just a plain old square. So look at that shape. Isn't it a beauty? So next you'll start to tile your plane. What you're going to do is match these up. You're going to trace onto a sheet of paper the shape that you just made. Then you're going to shift it over so that it lines up, and you're going to trace the second one, and then the third, and then the fourth, and you're going to keep tracing until you fill up an entire sheet of paper. Finally, you're going to look at the shape and make it creative. Do something more than just a blob, but look for a shape within the shape. And finally, add some color. Again, make it interesting. Do something that pops and grabs the attention. This is your opportunity to be creative in math class.